Let us solve for x comma y if x square plus x equal to y cube minus y and y square plus y equal to x cube minus x. So let's write this one as equation 1 and this one as equation 2. You see that we have got some kind of symmetric x cube, y cube, xy, y cube, x cube, minus y minus x. Let's subtract equation 2 from equation 1. So we write minus, 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 plus will change to minus when subtracting and minus will change to plus. So x square minus y square and then x minus y equal to y cube minus x cube, then minus changes to plus, so plus x minus y. Oh, you can see that we can cancel something out. X gets cancelled, so does minus y. And let's write everything to the left hand side. So that implies x square minus y square plus x cube minus y cube equal to 0. Wow, we can see further that we can factorize it. We can take x minus y common. We can take x minus y common. Let's do it. So we want to factorize x square minus y square. We know that a square minus b square equal to a minus b, here x minus y, into x plus y. What about a cube minus b cube? That's a minus b, so x minus y into a square, so x square plus xy plus y square. Pretty simple, right? Okay, now let's take x minus y common. So when I take x minus y common, I'm left out with x plus y plus x square plus xy plus y square equal to 0 as it is. Now you see that we have product of two numbers equal to 0. So we must have that one of them has to be 0. Maybe both of them are 0, but I can say that at least one of them has to be 0. So I can say that either x minus y equal to 0 or x plus y plus x square plus xy plus y square equal to 0. Let's look at the easier case first. X minus y equal to 0. So case 1, x minus y equal to 0. That can be written as y equal to x. Now, let's look at the equation 1. If I write y equal to x, maybe I can solve it. So, by equation 1, in equation 1, we are having x square plus x equal to y cube minus y. So, x square plus x we copy as it is. So, it follows from equation 1 that x square plus x we copy as it is. What about right hand side? We are taking y equal to x in this case. So x cube minus x. So x square plus x equal to x cube minus x. Okay, can I cancel something? Yes, we can cancel x. But before that, let's make it something equal to 0. So we take everything to the right hand side. 0 equal to x cube. X changes to minus x, so minus 2x minus x square. So x cube minus 2x minus x square equal to 0. That can be written as x cube minus x square minus 2x equal to 0. Now we take x common and we will be left out with x square minus x minus 2 equal to 0. Remember, if we have cancelled x out, maybe we could have cancelled, then we will not be getting one solution. Rather, we may not get one solution, x equal to 0. Now again, if you see product of two number equal to 0, so we can say that either x equal to 0 or x square minus x minus 2 equal to 0. It might be possible that both of them are 0, but at least one of them has to be 0. If x equal to 0, then we can find out y. What if x square minus x minus 2 equal to 0? Now we see that this is a quadratic equation, and we can simply factorize it by splitting the middle term. So the middle term is minus x, that can be written as minus 2x plus x. Minus 2 can be written as minus 2 into 1 equal to 0 as it is. So minus 2 plus 1 is minus 1, minus 2 into 1 is minus 2. So you have got a middle term written as sum of two quantity, rather difference of two quantity, and their product is minus 2. So we apply splitting the middle term. Middle term is minus 1 is broken as minus 2 and 1. So if I take x common, I will be left out with x minus 2. And then I can take 1 common, so x minus 2 into x plus 1 equal to 0. From there we conclude that x equal to minus 1 comma 2. Okay, we got three choices of x. Again, for x equal to 0, by equation 1, in equation 1 we have y cube minus y equal to x square plus x. If I take x equal to 0, then I get y cube minus y equal to 0. Y cube minus y equal to 0, that gives us y equal to 0. Y equal to 0. If I take y common, and then y square minus 1 equal to 0. Y square minus 1 equal to 0, that gives us y equal to plus minus 1. Therefore, we get x comma y equal to 0 comma 0. That's obvious solution. Both the equations are x equal to 0, y equal to 0, x equal to 0, y equal to 0. Both equation 1 and 2 will be satisfied. When I take x equal to 0, y equal to 0, and then when I take x equal to 0, x equal to 0, y equal to minus 1 and y equal to minus 1, that also is another solution. Comma 0 comma minus 1. Observe that x equal to 0 and y equal to 1 is not a solution of equation 2, so we reject such a choice. So we reject the case y equal to 1 when x equal to 0, because in that case we don't find a solution that satisfies the equation 2. X equal to 0, right hand side is 0, y equal to 1, left hand side is 2. So that is not true. 2 equal to 0 is not true. So we have started in this case by taking y equal to x, and we got two solutions, x comma y equal to 0 comma 0 and 0 comma minus 1, even though y is not equal to x in this case, but we are still getting solution fine. What about the other case? What if that x minus y were not equal to 0, but x plus y plus x square plus xy plus y square were equal to 0? Let's look at the second case. So case 2, x plus y plus x square plus xy plus y square equal to 0. Now we see that we look at equation 1, or rather, yes, we look at equation 1, we got x square plus x equal to y cube minus y. And in this case, we know x square plus x equal to, this implies x square plus x equal to, we take other quantities to the right hand side, so y square minus xy minus y. But by equation 1, once again by equation 1, x square plus x equal to y cube minus y. So but by equation 1, x square plus x equal to y cube minus y. If left hand side are equal, both are x square plus x, right hand side must also be equal. Therefore it follows that right hand side must be equal. So y cube minus y equal to minus y square minus xy minus y. Well, I can cancel minus y from left hand side and right hand side. Let's do it. And let's take everything to the left hand side. So y cube plus y square plus xy equal to 0. Now we take y common. If I take y common, then I'm left out with y square plus y plus x equal to 0. Once again, if product of two numbers equal to 0, one of them has to be 0. Either y has to be. So y equal to 0 or y square plus y plus x equal to 0. If y equal to 0, then by equation 1, x square plus x must be equal to 0. X square plus x must be equal to 0. Then of course we can factorize it. So from there it follows that if I take x common, x into x plus 1 equal to 0. From there we conclude x equal to 0, comma minus 1. So the solution are 0, comma 0, x, comma y equal to 0, comma 0 and minus 1, comma 0. X is 0, y is 0, x is minus 1, y is 0. So if y were equal to 0, then x comma y turns out to be 0, comma 0 and minus 1, comma 0. What if y were not equal to 0? Then y square plus y plus x equal to 0. Then y square plus y plus x equal to 0. But by equation 2, if you look at equation 2, y square plus y equal to x cube minus x. From this equation we see that y square plus y equal to minus x, and from this equation we see that y square plus y equal to x cube minus x. So we can combine these two to say x cube minus x equal to minus x. We cancel minus x out, so x cube equal to 0. So from there we conclude x equal to 0. And when x equal to 0, then it follows by case 1 that for x equal to 0, x comma y equal to 0, comma 0 and 0, comma minus 1. So our final solution is in case 1 we got x comma y equal to 0, comma 0 and 0, comma minus 1. And in case 2 we have obtained x comma y equal to 0, comma 0 once again and minus 1, comma 0. So those three pairs are the only solution of the given equations.